So today we are going to discuss two more laws of chemical combination. Yesterday we did two laws, today two more laws. One is law of multiple proportion and another is Gay-Lussac's law of combining volumes. So these two laws we are going to discuss today. Now third law is law of multiple proportion. This law was given by Dalton. This pic which you can see is of John Dalton. So this is Dalton. He gave the law of multiple proportion. Now what this law states: when two elements combine to form two or more than two compounds, then the different weights of one of the element which combine with the fixed weight of the another means bear a simple whole number ratio. Now what is to be checked? We have to take two elements and they should be able to form two compounds or more than two compounds. Okay. Now if it is the case, then we will fix weight of one of the element. We will fix weight of one of the element and we will check how much weight of another element requires for combining with the fixed weight of this element. Now that weight in both the compounds, we will take the ratio. That ratio will be a simple whole number ratio. Now one example we have taken: carbon combines with oxygen and it forms carbon monoxide CO as well as carbon dioxide CO2. So CO and CO2, these two compounds are formed by the combination of carbon and oxygen. Now how it is applicable in this case? Okay, now see, this is carbon monoxide which is formed by the combination of C and O. This is CO2 which is formed by the combination of C and O. Now in this compound, what is the mass of carbon? It is 12. In this compound also there is only one carbon, so mass of carbon is 12. Now in this compound there is one oxygen, so mass of oxygen in this case is 16. In this case there are two atoms, so mass of oxygen is 32. Now if we fix, suppose we fixed the mass of carbon and the fixed mass is 12, then what is the mass of oxygen which will combine with this fixed mass? In case of CO it will be 16. In case of CO2 it will be 32. Now we will take the ratio of these two. This ratio will be, if taken CO is to CO2, then it will be 1:2, and if I have taken CO2 is to CO, then it will be 2:1. So here we have taken the ratio of O in CO2 is to CO. So in CO2 is to CO, it is like 2:1. So this is law of multiple proportion. Now we come to next law. Now as the name suggests, this law was given by Gay-Lussac. This law was given by Gay-Lussac. This is Gay-Lussac. Now what is the law? See, this law is for gases. Here this is the product formed in gaseous state, this is the reactant in gaseous state, this is the reactant in gaseous state. So these two reactants have combined in a gaseous state to form this particular reactant in this particular product in gaseous state. So what is the law? When gases combine or are produced in a chemical reaction, just like this is produced in this reaction, they do so in a simple ratio by volume. They do so in a simple ratio by volume. Now see, in this case what happens? 1 mole of hydrogen combines with 1 mole of chlorine and it gives 2 moles of hydrochloric acid. So these three reactants as well as products, they are in gaseous state. So the ratio in reactants and products, when all are in gaseous state, it will always be in a simple whole number ratio. This is Gay-Lussac's law of combining volumes. Now these two laws you have done today. So this is the assignment for you. You have to do it. Okay, thank you.